Hi, I just need to describe about one of the assignment problem regarding our linear regressions, and there are steps that we need to follow initially while putting this assignments. We had a linear regression assignments going on, and first of all I need to briefly explain the assignment problem which we had and how we tackled for doing the solutions. So we had a problem where we had a Chinese automobile company, some X and Y, which company aspires to enter the US market, and by setting up some of their manufacturing units and like producing their cars, and then to have some competitions in their US markets with the counterparts. So they have contacted an automobile consulting company through which they can understand the factors which are mainly affecting the cars demand. So to specifically understand those factors, we have to modify we have to do our assignment analysis while which are affecting the prices in of the car in the American markets, so which are getting varied from the Chinese market. So the main factors which we included here are like the variables which are significant for predicting the price of the car, and how well these variables are affecting in describing the price of the cars. So based on some of the market surveys, this consulting firm need to gather large data sets which come as a car marketing price data sets here in our assignment modules, that are which are basically typically a bit different from the American markets. So there are basics approaches or lined up questions which have uh, for making this video. So first of all, why do we use linear regressions? So linear regressions is for linear regression should be a common statistical techniques, and it is basically used to determine the extent of dependent relationship between a dependent variable and independent variable, or one or more independent variable. So in simple linear regressions, when we describe as when a single independent dependent is to predict the value of a dependent variable, and in case of multiple linear regressions, when a two or more independent variables are used to predict the value of a dependent variable. So this is what mostly defines as definition difference between a simple linear regression and multiple linear regressions. Now, what initially we did for our this assignment for this Chinese car automobile process. First of all, we did some analysis of the data sets which have, and then we primarily did some data cleaning, and then we start with the data modeling. For data cleaning should be that. First of all, why should we use linear regression? Linear regression comes when we have a categorical variable and a class and a classical variables available in the data sets. So for differentiating those variables, we need to have the linear regressions model. So, and we have to think also about the outliers when we think about analyzing the data sets. Now the next questions which we have lined up: what is stepwise function? A stepwise is a method which we have for primarily for basically for we need to remember that while analyzing this any data set, any model, any of the arbitrary unstructured uncleaned data using linear regressions, we need to first have those packages installed. One is car libraries we have to first install, and a step functions, that step AIC function. So moving on to step feature selection. Stepwise selections is a method that allows moves in either directions, that can be bidirections, like dropping or adding values at various steps. Now uh, taking up the questions, like which of this method is better suitable, like forward, backward, or both. So I think that for both of these in both of these scenarios, like I think that both of these variables take same thing, but it depend upon two factors, like a non-factor factor co-facility and without any factors. Now moving on to next questions, like there is multicollinearity. Multicollinearity is a uh, steps that in statistics in which a phenomena is being taken care of, or any one predicted variables which is x or y, which is we take it as a y in a multiple regressions model, which can be linearly predicted with others having the other substantial degree of accuracy. Now there rise another questions: if there are two predictors which are correlated and both are included in the model, then in this scenario one of the model will become insignificant. Now moving on to some of the other factors, like variable incapability factors, that is VIF factors, which we have also used in this linear regression assignments. And then moving on to some of the other questions, that what I can recall, that there are some assumptions of linear regressions model. So in linear regressions assumptions, we have some lined up some few of the key assumptions which are like linear relationship, and then I can take about multivariate normality, and then little multi-correlationality or autocorrelation. There is no autocorrelations or homoelasticity. So moving on to this point, homoelasticity. Homoelasticity is a term which is a sequence or a vector of random variables is homoelastic. So if any random variable in the sequence or vector has the same infinite invariance, this is known as a homogeneity of a variables, and this complementary notion of that idea is heteroacidity. So these are basic steps which I followed, and moving on to the assignments analysis, we did check the RSS value and the significance of each of the variables which are counting in the module. For example, in this assignment we have taken price as a dependent variable, other as independent variables. So we have checked what are the variables which have made dependent, which have made factors on the price of this car data sets, and we have taken, and we at least take for the RSS value and the we have taken the R square and the R square values for the adjustment, and we have taken the variance, how the simplicity the model is. So these are what we have analyzed and we have taken care. But basically we have gone through the 70-30% of the analysis, like while taking the train and a test data for any of the data sets. That's what. Thank you. Signing off.